Our next lesson deals with angles. There's quite a bit of this you learned in elementary school, but there are some new things in today's lesson, so make sure that you're paying attention, please. How do I identify and measure angles? All right, well, let's start off with what even is an angle? Let's go back to the basic definition. An angle is formed by two rays with a common endpoint. All right, so if we look at our example over here on the left, right, we have ray BA and ray BC. Together they form the angle ABC. The common endpoint is called the vertex, and the rays are called the sides. You name an angle using 3 capital letters. The middle letter must be the vertex. For a second there, I couldn't remember what I wanted in the blanks. So if I look at this example over here on the left, I use a little baby angle symbol, angle ABC. Or I could say angle CBA. You can only use a single letter to name an angle if there is only one angle located at the vertex. In this case, we only have the one acute angle, so I could also call it angle B. Angles are congruent if they have the same measure. Remember that angles are measured in degrees, and you need a degree symbol when you write down an angle measurement. When we refer to the measure of an angle, we use a lowercase m in front. So again, looking over here to the left side, I would say the measure of angle ABC equals 60 degrees. This angle symbol that I'm drawing, right, it looks a lot like the less than symbol, except you're supposed to flatten the bottom. My handwriting's not very good, okay? So I always put an arc through it so that you can definitely tell it's an angle and not a less than symbol. Unless you have outstanding handwriting, I suggest you do the same. So what are the basic types of angles? How many do you think there are? Well, there are 5. Acute angles measure between 0 degrees and 90 degrees. So, for example, here's a 30-degree angle. Obtuse angles measure between 90 degrees and 180 degrees. So for example, this one's, I'm going to say 150. Right angles measure exactly 90 degrees. And we put the little right angle symbol in there so that people know we have drawn a right angle. You may or may not have learned this one in middle school, straight angles. Measure exactly 180 degrees. Straight angles look like a line. To tell the difference, we usually put a point and a little arc on it. Not always, but usually. And finally, one that is probably new is the reflex angle, which measures between 180 degrees and 360 degrees. So if you have a reflex angle, we draw this partial circle around the outside of the vertex to tell you, don't measure the acute, you're looking for the reflex. All right, if it's obtuse, it would look like that. If it's right, it would look like that. So, another postulate, because we need one. Oh, let me back up a second. I forgot to highlight. Yeah, I know. You're excited, right? I forgot to highlight acute angles, obtuse angles, right angles, straight angles, and reflex angle. You've got vocabulary you have to know. All right, back to the protractor postulate. Consider point A on one side of OB. The rays that form OA can be matched 1-to-1 with the real numbers from 0 to 180. The measure of angle AOB is equal to the absolute value of the difference between the real numbers for ray OA and ray OB. This is what allowed you to measure those angles in elementary school. We don't do any measuring with protractors this year. You will do some measuring with protractors again in pre-calc. Okay. But we have another addition postulate, and this one deals with angles. So this idea again of the part plus the part equals the whole is very important mathematically. In this case, point P is on the interior of angle RST. So that means, and it looks like my symbols didn't quite print here in the diagram, the measure of angle RSP plus the measure of angle PST equals the measure of angle RST. The part plus the part equals the whole. So let's do a little practice. I want you to go ahead and try this page on your own. Pause the video. All right. The vertex here is K. Remember that the sides are rays, and when you name a ray, you have to start with the initial point. Then the second point the ray is going through, the ray symbol always has to point to the right. So be really careful about that. Make sure when you're naming the angle, you've got the angle symbol in front. And make sure when you classify the angle, you just don't say obtuse. It's an obtuse angle. Next diagram got a little more interesting. In addition to naming our angles using letters, we had so many angles going on, these were numbered. I do that a lot when my diagrams get complicated. I don't want to have to write angle WTZ over and over and over again. It's easier for me to write angle 4 as an example. All right, on the next page, you are going to be using the angle addition postulate. I want you to pause the video and give these a try. All right, so the first one was very straightforward. I labeled my angles and the part plus the part equaled the whole. The second one, I had to set up a small equation. Maybe you could figure it out using mental math, but note that I was careful to use the proper notation when I wrote my final answer. The measure of angle IHQ equals 46 degrees. For number 3, I was only asked to solve for x. And for number 4, I was only asked to solve for x. All right, at this point, you should write a summary. Be sure you include the angle addition postulate in your summary.